Obviously, the best experiment that one could do would be to get a bunch of kids, randomly assign them to a group where they do not ever learn to read, and randomly assign another bunch of kids to a group where they do learn to read, and then test their intelligence later. But of course, that's somewhat unethical,
Hmm. Yeah.
given that it's quite important to learn to read. So the next best thing is to look at is to instead of having a control group of kids who learn to read and kids who don't, is to look at a natural experiment. And of course, that's what identical twins are. They're genetically identical clones of each other, and so we've got this beautiful natural experiment where you have these identical twins, and for whatever reason they vary in their reading level at an earlier time point, and we can see if that variation in reading level is related to the variation in their intelligence level later in their development.
Tell me a little bit about this twin study. How many twins have you got, and what did you find when you looked at the differences in their reading and their intelligence?
What we did here was we looked at only identical twins. And so we had about 1,890 pairs of twins in this study, which is the Twins Early Development Study, TEDS. These twins have been tested for both reading and intelligence at several different ages across their development. So they've been tested at age, we had data from age 7, 9, 10, 12, and 16. And so what we did was we looked within a pair of twins, and of course, those pair of twins, since they're identical, they share all their genes and they share the socioeconomic environment that they grew up in. And so we looked at any differences in reading that were among those twins. And if there were differences, then these differences have to be caused by something in the non-shared environment. That is, something which one twin experiences but the other doesn't, that might make their reading better or worse than their twin.
So, when you found this association between reading ability and intelligence, what do you think it means?
Well, so the basic finding is that the twin with better reading ability at time A will have better intelligence test performance at time B. But it does raise more questions than it answers in that what exactly is happening. The big sort of limitation of the study is we don't know what caused those reading ability differences in the first place. Was it a teacher that one twin had that the other didn't, that encouraged them to read? Was it a book that one of them found that they loved and it started them off on a sort of an interest in reading? Or was it something else? It's hard to say. One possible hypothesis, if the effect that we found was causal, one possible hypothesis for that, which would need to be tested in future studies, is that learning to read improves your ability to do abstract thought. Because the most interesting thing that we found was that it wasn't just verbal intelligence tests that were associated with earlier reading differences. It was non-verbal intelligence tests too. So puzzles, pattern completion puzzle. And so it seems like reading is improving these non-verbal skills too, which might imply that reading opens us up to abstract abilities, given that you have to, when you're reading, you have to think about other times and places and people and use more abstract skills.
And obviously, some kids are complete bookworms and some aren't, and some children struggle to learn to read. And does this mean automatically that they're going to be less smart later in life? What can we do about children that do struggle to read?
Well, one of the big things to say is we know that there are large genetic contributions to reading and intelligence. So we know that some children struggle to read because of genetic problems. We know that dyslexia is influenced by genetic differences, for instance. It doesn't necessarily mean that children who are poor at reading will be poor on intelligence tests. In fact, but what it might mean is for normal kids that having poorer reading instruction, they might be missing out on the benefits that literacy can give to more general cognitive abilities.
So, if any parents are listening or people are thinking, I want to have a smart kid that grows into a smart adult, should they just surround them with books?
It would be going too far from our study to conclude that, since we didn't rule out all possible sort of confounding effects. But one thing to say is that it certainly won't harm the kids if you surround them with books.